Good. So that's air scrubbing. I hope I didn't go too fast. I mean, obviously you can ask questions afterwards. And now on to the second bit is really about energy recovery. Plus actually is a company that came from a place of optimizing climates in houses before it got into air scrubbing. But what my boss realized was that, apart from pollutants coming out the end of the house, we're also throwing out a lot of energy. In the winter, we have to warm the buildings. Summer, we're obviously cooling them, but the animals are still producing heat. And so all of that energy is literally just getting thrown away on a daily basis. So we've developed a system where we gather that energy. So here you have a picture of a pig house. This is a pig house with a central duct at the end. So it's slightly different to the one that we first saw with all the fans along the front. The air comes out of this central duct. You see all the fans at the top in the ridge, goes down into what we call the pressure room, where the air is allowed to mix, comes out through the pressure room into the air scrubber, where the cleaning process takes place. But at the same time, the warm air is warming up the wastewater, the washing water. And what we're doing is we're using a specially designed heat exchanger to transfer that dirty water energy through a piping system to a point in the house where we then reuse it to precondition the air, namely in the winter when we're warming it. We have a slightly different system to use a similar approach for cooling, but I won't go into that today. Just at the moment, we'll focus on the warming of the house air before it goes in. So it's a very, very simple process. Here is the schematic of it to make it look maybe a little bit simpler. Here we have the air scrubber. As I say, it's gathering energy from the animal house. Typically, the wash water will warm to about 20 degrees, okay? We have an exchange technology, which I'll show you a little bit in a minute, called a EEE. Now, this technology has a COP, that means a covariance efficiency factor of around 50. And what we mean by that is by using 1 kilowatt of electricity, we can gather around 50 kilowatts of thermal energy and reuse that. So that's quite an efficient way to reuse energy. We can do higher, but in production, typically that's what we see, okay? And then what we would do is we would take that energy first of all and transfer it to an inlet where, say for example, in the winter, and I'll show you an example in a minute, maybe it's outside. In the Netherlands last year, we were down to -10 degrees, right? And we can then precondition that air, take it up to +10 degrees, okay? So immediately we're starting to say, fossil fuel savings can be quite significant because now we're using animal energy to do the preconditioning. What we can also do is we can then hang, for example, a heat pump where the covariance is less. It's only 1 in 4, significantly less, but it still can be, depending on the cost of electricity, it can be quite an efficient way to take the +10 degrees up to above 30, probably namely 40, 45 degrees. So that gives us the added benefit then of, as the air goes into the house, for example, with small animals or piglets or chicks where they haven't got the ability to keep themselves warm, it means that we're bridging quite a large temperature gap from -10 to maybe +40 if necessary. Ideally, a chicken only wants 30 degrees. But we bridge that gap with a very, very efficient use of the energy that we've gathered in the air scrubber. And that has there's twofold. It has a significant benefit in terms of the cost of energy. It means that we're using an available resource that was only getting thrown away. So in terms of carbon footprint, we are not destroying the planet by burning fossil fuels. But the other big advantage, and maybe some farmers will tell you this, is that in the winter, farmers tend not to ventilate the houses as well as they should because it costs a lot of money. And by not doing that, it means that the animals become challenged, with disease, stress, etc. And perhaps the temperature going to the house isn't as warm as it should be, so they use feed, etc., to keep themselves warm. So the added benefit is by ventilating the house properly at the right temperature, there's a massive gain in terms of how the animals perform, and therefore the feed consumption. Going back to that first graph where we have that big footprint of feed consumption, we can improve that by maybe up to 10%. Certainly with pigs, up to 10% feed improvement, which is a massive, massive gains in terms of our carbon footprint. So that possibly answers one of Ed's questions. What does it look like in practice? This is literally a screen that's pulled off one of our systems. This was last, as I say, I think this was last winter, because it did get quite cold here. Here's the air scrubber. The energy we were pulling out at that particular moment, because I can see that the system during a particularly cold patch will labor more than it would normally. It was pulling at 13.1 degrees, that transferred over the exchanger, took it to 11.7, and we were managing to bring the minus 0.83 outside temperatures to 9.1. So that was quite a significant gain. What you'll notice here, the COP was running at 22.6 because probably the system was working hard, and at that particular moment was probably using more electrical energy than it would normally do if it wasn't challenged as much as it would normally. So it gives you an idea of how the system works and what the benefit can be from gathering energy from air scrubbing. And this is just a graph of the same thing. Here we have, this is the outside temperature going through a period. This is the green one is the wash water temperature. See, that goes up and down a little bit, but this is the preconditioned air going into the house, and you can see it's consistent the whole way through. There's a few glitches, but pretty consistent. And as I say, when we speak to farmers where they do optimize the air like this, the feed benefit can be quite significant. Okay. And then before I get on to some financials in terms of how we scale up and pay for this, this is again just an example of roughly what it would cost to install such a system. This is a pig farm in the Netherlands. I think it's 400 sows and about 2,700 piglet places. The system total, that's the cost of the air scrubbers, heat pumps, etc., cost around 116,000 euros. The energy saving per year, around 10,500 from the Tripoli. Heat pumps slightly less, but there was still a saving. And then quite a big saving in terms of production, and that would have been mortality of animals, because the animals do die when they're under stress, and feed consumption savings. So the total saving a year the farmer was experiencing, or is experiencing, is around 30,000 euros a year, and the system cost him 116. So, a return on investment of 3.8 years in this particular situation. In terms of energy recovery, we see average is probably 4.5 to 5 years would be the typical payback on a system like this.